Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look through surds. So we need to know about surds because they come up in so many different areas of maths, like roots of polynomials that we'll look at later. So what is a surd? Well, we know that if we take the square root of a non-perfect square, the number is irrational. We call these special type of irrational numbers surds. So for example, the square root of 5 is a surd because 5 is not a perfect square. This number here is irrational. So we're going to look at performing operations with surds. So multiplying and dividing surds is easy. We can just follow these rules. Square root of 5 times square root of 2 is just the square root of 5 times 2, which is 10. So that's what it's saying here. Square root of A times square root of B is just the square root of their product. So what about the square root of 80 divided by 4? Well, you know that that 4 is the square root of 16, so we can write it like this. So the square root of 80 divides square root of 16 is just the square root. 80 divided 16 is 5. So adding or subtracting surds is a little more challenging because we can only add or subtract like surds. So this is akin to like terms in algebra. So if we have something like root 5, root 7 here, think of this as like an x and this is like a y. So if we had x plus 3y minus 2x, well, you can only add or subtract these two because they're like terms. So to simplify this, root 5 minus 2 root 5 just gives us negative root 5. Now we're going to leave the 3 root 7 alone because there are no like surds. So we can't simplify this any further. So adding or subtracting surds is kind of like adding or subtracting terms in algebra. There is, however, an exception. You may need to simplify surds first. So root 98 and root 50 don't look like surds, but they actually are. We need to simplify them. So what does it mean to simplify a surd? Well, just like simplifying a fraction, what we want to do is we want to find a number that's equal to this, that's equivalent, but has a smaller number under the square root. So how are we going to do that? We're going to use this principle here. What you need to do to simplify root 98 is find the highest perfect square that goes into 98. So that turns out to be 49. See, root 98 can be written as the square root of 49 times the square root of 2. The reason I chose 49 and 2 rather than like 7 and 14, 49 is a perfect square. Square root of 49 is just 7. So square root of 98 is the same as 7 root 2. So similarly, for square root of 50, we need to find the highest square number, highest perfect square that goes into 50. Well, that happens to be 25. Root 50 is the same as root 25 times root 2. Of course, root 25 is just 5. So 7 root 2 is root 98. Root 50 is 5 root 2. Now you can see we actually can subtract these two surds here. They actually are like surds. 7 root 2 minus 5 root 2 is just 2 root 2. Of course, not every surd can be simplified, just as not every fraction can be simplified. This is because some numbers are not divisible by any perfect squares other than 1. So there's no perfect square that goes into 5 or 7 other than 1. That's why I couldn't simplify these surds. All right, let's now look at rationalizing the denominator. So when we want to rationalize the denominator, we want to find something that's equal to our number but has a rational denominator. Of course, root 5 minus 1 is irrational, because when you take irrational and you add or subtract irrational, the answer is always irrational. So how are we going to rewrite this so it's the same number, but it has a rational denominator? Well, we can use this rule here, which is called the difference of two squares. A plus b times a minus b. You just square the first, square the second, and then stick a minus in front. How is that going to help us? Well, what we're going to do is we're going to times the denominator of this fraction by root 5 plus 1. So why are we going to do that? Well, this rule here means square root of 5 minus 1 times square root of 5 plus 1. You just square the first. Root 5 squared is 5. 1 squared is 1. And you stick a minus between them. So if I multiply root 5 minus 1 and root 5 plus 1, I will get a rational answer. But hang on, you can't just times the denominator by whatever you want. Remember, what you do to the denominator, you have to do the numerator. So because I times the denominator by root 5 plus 1, I must also times the numerator by root 5 plus 1. So to do this, we use our FOIL. So we go 3 times root 5 is, of course, 3 root 5. Then we go 3 times 1 is just 3. Root 2 times root 5 is, of course, root 10. And then lastly, root 2 times 1 is just root 2. So, making this a little easier to understand, on the top we have no terms that we can simplify here, but on the bottom we can just make this 4. And that's our final answer. These two numbers are equal, but this one has a rational denominator. We're going to perform a similar trick in the next lesson to divide complex numbers. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.